BalamSemiconductor Podcast, Episode 2. From RTL to Silicon, Design Flows for Chips and FPGAs. Welcome to BalamSemiconductor, the podcast where circuit design comes to life. I'm Carlos Alberto Hernández-Gutiérrez, and today we're diving into one of the most critical paths in the semiconductor industry. The journey from RTL design to final implementation in a chip or FPGA. What happens between writing Verilog and having a working circuit? Let's explore. In the last episode, we discussed RTL, or Register Transfer Level, which is the starting point of the digital design flow. At this stage, the functional behavior of the digital system is defined using languages like Verilog or VHDL. Companies like ARM, Synopsys, and Cadence provide IP cores and EDA tools to model, simulate, and verify these designs before any physical implementation. ASIC flow, from RTL to GDSII. If the design is heading to silicon as an ASIC, the flow begins with the front end. Functional verification. Simulation using UVM and system Verilog to catch early bugs. A logic synthesis converts RTL into gate-level netlists. DFT, design for test-add structures like scan chains to ensure post-silicon testability. Then we move to the back-end. Floor planning, placement and routing. Clock tree synthesis, CTS. Static timing analysis, STA. Physical verification, DRC-LVS. The final step is generating the GDSII file, the physical layout of the chip, which is sent to foundries like TSMC or global foundries for fabrication. FPGA flow, a more direct path. For FPGAs, the flow is much shorter. RTL goes through synthesis tools like Vivado, Quartus, or GoWin IDE. Then comes logic mapping and place and route. Finally, a bit stream is generated to program the FPGA device. There's no need for GDSII, STA, or DRC. It's faster and ideal for prototyping and education. While faster and suitable for prototyping and education, it's important to remember that FPGAs are also used in many commercial products. Why a good RTL design matters. A well-written RTL design avoids costly mistakes later in the flow. It helps meet constraints for frequency, area, and power consumption. Understanding the full flow helps engineers write cleaner, synthesizable, and implementation-ready code. Whether for ASIC or FPGA, it all starts with good RTL. That was BalamSemiconductor. Today, we explored the path a design takes from RTL to a real chip or working FPGA system. In the next episode, we'll cover the difference between combinational and sequential logic in Verilog. Until then, keep thinking in hardware, because the future is built by semiconductors using HDL.